Seema? Seema, come to the kitchen. I should have just bought the milk myself yesterday. Can't rely on anybody nowadays. Yes, Mama, do you need help? Yes, I had to make some custard before I leave for office, but seems like your dad forgot the milk again. So would you please mind running to the store once for me? Yes, sure, why not? I'll go grab a packet of milk from the store. Whew, here's your milk. I got it. See, it even says pure milk on the packet. I guess we're having good dessert tonight. You are such a darling. Now let me make the custard so that we can enjoy the dessert. Alright? Yup, right, Mama. So thank God you're home. So tell me, in the morning you were telling me that something about pure milk not being pure. Tell me, I want to know more. You really do want to know more? So listen. The literal meaning of the term pure milk, written on the packet, signifies that it contains proper proportion of water, proteins, carbohydrates, fats, and mineral salts that are commonly present in milk. So there is no need for you to get confused. I know it says pure, but it's not pure. It's confusing, I get it. So let's do something. Let's watch a video that I came across so you'll understand more about this. Hello and a warm welcome to Notebook. Today we shall learn about an interesting topic of science. Is matter around us pure? From your syllabus. As Roald Hoffmann had said, chemistry is the science of molecules and their transformation. So without further ado, let's dive headfirst into a vast universe called matter. Matter is anything that has mass and volume, or we can say that it is anything that has mass and occupies space and can be felt by one or more sense organs. Everything that you see around you, books, pens, water, everything is matter. We can classify matter into pure substances and mixtures. In this video, we shall be discussing only about pure substances. Elements and compounds are examples of pure substances. Oxygen, which is one of the most important gases present on the earth and is required by almost all living beings for respiration, is the most abundant element. The term element was first used by Robert Boyle in 1661. Later, Antoine Lavoisier, a French chemist, gave the modern definition of element. According to him, an element is a pure substance which cannot be broken down into simpler substances by chemical means. There are 118 elements, in which 92 are naturally occurring and the remaining are prepared artificially in the lab. Let us try thinking of some examples of elements apart from oxygen. Carbon, silicon, copper, iron, zinc, mercury, silver, gold are some examples of elements. Friends, we can classify elements into metals, non-metals, and semi-metals. When we talk about metals, we think of iron, gold, silver, copper, etc. Iron is a classic example of metal. It can be hammered into sheets, that is, it is malleable, drawn into wires, or it is ductile, and produces a ringing sound when hit, that is, it possesses sonority. Hence, to describe metals, we can say that a metal is a substance which is malleable, ductile, sonorous, and conduct heat and electricity. They are also lustrous or shiny in appearance when freshly cut. Think about mercury, which is a liquid metal and is used inside the bulb of a thermometer. Let us now discuss about non-metals. Oxygen, hydrogen, iodine, bromine, carbon, chlorine are some examples of non-metals. So, in order to describe non-metals, we can say that a non-metal is a substance that is neither malleable nor ductile and does not conduct heat and electricity. They are non-lustrous, though graphite, a form of carbon, shows metallic luster. Bromine is the only non-metallic element that exists as a liquid at normal conditions of temperature and pressure, while iodine, forms of carbon such as diamond and graphite, exist as a solid at normal conditions of temperature and pressure. Let us now know some fun facts on metals and nonmetals. Did you know that the most reactive metal is francium and the most reactive nonmetal is fluorine? Another one perhaps? Osmium is the heaviest metal and astatine is the heaviest nonmetal. Okay, last one. The best conductor among metals is silver and the best conductor among nonmetals is graphite, a form of carbon. The last type of elements that we shall discuss is semimetals. Elements which behave both like metals and nonmetals are called semimetals. They have intermediate properties between those of metals and nonmetals. Some common examples of semimetals includes germanium, silicon, arsenic, antimony, etc. Now that we have understood elements in detail, let us discuss about the second type of pure substance, which are compounds. Think about water. The chemical formula of water is H2O. It is a compound which is made up of hydrogen and oxygen chemically combined in the ratio 1:8 by mass. Here, hydrogen and oxygen are elements which combine to form a compound. The same goes for carbon dioxide. CO2 is where the elements carbon and oxygen combine in the ratio of 3:8 by mass to form a compound. Hence, we can say that a chemical compound is a chemical substance composed of more than one kind of elements in a definite proportion by mass. Friends, did you know that the physical and chemical properties of a compound is completely different from those of its constituents, from which the compound is formed? For example, hydrogen is a highly inflammable gas and oxygen is also a gas which supports combustion, whereas water is a liquid and acts as a fire extinguisher. Well, with that, we conclude our today's discussion on the topic pure substances. We really hope that you have enjoyed learning with us today and have been able to get a clear idea about this topic. We shall meet you soon in our next part of the chapter where we are going to discuss all about mixtures. Till then, stay healthy, keep learning, goodbye.